Okay. So, on this one, what would you say that the period of this graph is? How often does it repeat itself? Remember how cosine and sine, it was 2 pi, right? That's how long the period was normally. How about tangent? Pi. Yeah, 1 pi. Because, see, it goes from pi over 2 to 3 pi over 2 is one section, right? And then it starts repeating. Does the exact same thing again. So it goes from 1/2 to 1 1/2. That is a length of 1 pi, or just pi. The amplitude, there is none. I was going to say no, and then I said none instead and went newen. None. No amplitude. And by that, I don't mean that the amplitude is 0. I mean that it doesn't exist. Because that would kind of show how it's spreading. I guess you could kind of say that the amplitude will make it like flatter or more narrow, but it's not like, so like if there's a number in front of a tangent equation, if it was a high number, it would make it kind of stretch up a little bit more, and if it was a low number, it would make it kind of like lay down a little bit more, but it wouldn't ever be like a certain distance away or shift or anything like that. Domain and range. How far does it go left and right? How far does this graph go on the left, and how far does this graph go on the right? Infinity. So it's negative infinity to infinity, except for what? What are the places that it doesn't exist? Pi, it exists. Pi, it's at 0. You mean the asymptotes? Yeah. So except the asymptotes. Asymptotes are A, S, Y, M, P, T, O, T, E, S. That was cute. You all went except, and then you went eh. And everybody looked up at the same time like, I have no idea. How do you spell that? Has anybody had to write the word asymptote before? First moment? Oh, you have. Very cool. All right. Range. How high and how low does this go? Negative infinity to infinity. Are there any exceptions for the range? You don't think so? Because this one, let's see, look, this one's at 0, right? For y. And then it goes down. Is it skipping anything as it goes down? No. And does it keep going down forever? No. And does it skip anything as it goes down forever? No. Left and right is where we're missing things. We're missing this one and this one and this one. But just this thing right here, just this one, goes up forever and down forever. So the range is negative infinity to infinity.
Who decided that numbers go on forever?
Nobody decided. They just do.
Oh, it's just so weird.
It's like, who decided how many blades of grass are outside? Gross.
Well, like, there's not a stopping point. That's so weird.
Yeah. It's one of my favorite things when my kids were little is Zandy would always say, for some reason, he'd say, I love you 100, which I thought was very sweet. Right? He'd be like, guess how much I love you? And I'd be like, how much? He'd be like, 100. And I'd be like, wow. And I'd be like, I love you 101. And he'd be like, I love you 1,000. And I'm like, yeah, well, I love you 1,001. And he'd be like, like, it was so frustrating for him. He just keep going to higher numbers. And then at one point when he was like 4 or something, he was like, oh, so you just always a +1? And I was like, yeah. And he's like, huh. And I'm like, yeah, that's how it works. You can just always add 1 if you want to, man. All right, let's try graphing it. Go to y equals tangent of x. Clear, clear. Okay. So, let's make, what should we make our window? Right now we have it as, I have it as negative pi to 2 pi. What do you think? How many of these do you want to see? Do you want to see what we see here?
Yeah.
So where should we start then? 0, okay. And where are we going to go to? 2 pi. If we go to 2 pi, we'll see this much. So that's what our graph should look like. Everybody okay with this? Okay, all right, so we'll look like that. So we're gonna go from 0 to 2 pi, which is 6.28. Y minimum, let's go with -3 to 3, just like our graph shows. Make sure you're in radians. Now, let's say that we expanded that. Anybody not see this? Turn your calculator to your partner and show them.
Mine is not letting me go down. Like when I put this to go down.
What do you have?
I think it shows the lines for that aspect.
Let me see. That's a new calculator, not an old one. I was actually going to show you that on the old calculators. I'm surprised.
We're going too far.
I have no idea why. I wonder if this one is so old. I'm sure there's a reason, but I'll figure it out later. Okay, this is what it looks like when you're on this calculator, and what Sierra's currently seeing is what the old calculator would have shown you. So I'm gonna show you that quick. Weird,